speaker is Ahmad Abdelrazaq, who's going to speak about axial shortening. Ahmed is Vice President with Samsung C&T Corporation.
Obviously, I'm been trying to do the same thing for a while, and this is technically it's the first time we are starting this kind of work, and I think it's very significant in many ways because since the majority of the design guidelines or the work that has been done previously has not really been focused on some of the latest technological advances that we have, especially related to concrete material. Concrete is no longer the concrete that we knew in the past. Essentially, we are seeing a completely different trend. The concrete is becoming more of a composite material than really the traditional concrete that we know. And we have demonstrated this by doing in situ testing on Burj Dubai and also in the laboratory, both at Samsung laboratory and also at CTL, and based on a lot of research work that is being done presently. Obviously, at this moment, I thought that probably the best thing I can do, obviously I'm the only one, as you can see, there aren't many people. And we are recruiting people who are trying to contribute to this guideline. And the intent of it is not to just have it a general guideline, to have it really a good reference material that people can use in real practice. So the purpose of the design guideline is to provide a best practice approach for predicting and evaluating the column shortening for concrete, steel reinforced concrete column, CFTs, and steel members with due consideration to some of the latest technology in materials, such as high-performance concrete, high-strength steel, and ultra-high-strength concrete in particular that is exhibiting very low shrinkage, which means it's also very low drying creep. And also to take a look at the differential shortening and recommendation and compensation program for different type of buildings, whether it is concrete, steel, or composite. And we'll be presenting several case studies related to this. And also talk a little bit about the construction sequence analysis. Right now, who's responsible for this? Are the designer really responsible to do construction sequence analysis or the contractor? And a lot of time, engineers just leave it to the contractor to deal with these issues. And a lot of time, they're going in two different directions, and based on real experience. And at the same time, who's doing it? What kind of program are they using? What kind of available program do we have in the market that can deal with these issues? And are they good enough to deal with that, especially with many of the complex buildings that we are seeing today that are made out of concrete? And also to provide an overview of the history and characteristics of material in terms of verification and show in the verification and real time monitoring program. And again, with that, I would be looking for a lot of database. I have some, and I'm sure many engineers around the world have been collecting some of this data. It would be good to add it to the data bank of information to make sure that whatever we're recommending is a practical and correct. Historically, we didn't have a lot of data on this subject, but now we getting a little bit more. Obviously, there, for example, in a composite building, there are three different things we'll be concerned about: is relative shortening between a concrete core or steel column, or a concrete core and a composite column, or composite column and a steel column, and also looking in detail in terms of what kind of construction program that we have and how it relates to the actual construction. So the outline of the, obviously this is an overall outline. It's just still preliminary and a draft. It will consist of an introduction with the background, the scope, differential shortening, relative movement between adjacent members, as I spoke about, a prediction of elastic, shrinkage, creep, and temperature effects. Obviously, there literature review of all the different available models, plenty of them, ACI, European code, GL code, Australian code, and also strength development of these, with time, and also looking at the development of modulus of elasticity versus time for different type of concrete. A lot of data bank on concrete, but when it comes down to composite, what is the behavior and what kind of assumption we make is another challenge that we have to look into. Shrinkage evaluation and creep evaluation. Determine the elastic, shrinkage, and creep shortening for concrete and composite building, looking at total shortening, elastic, shrinkage, creep, temperature, and also construction sequence analysis. Review all the available software, as I mentioned earlier. Look at case studies. These are the preliminary ones that I put together that I know of, but anybody who can contribute more, I'll be happy to receive it, especially with Arab and SOM and any kind of organization internationally, it would be helpful. And also testing of materials in terms of a lot of time there aren't many good laboratories that can test for modulus of elasticity and creep in particular coefficients, so they have to be pretty sophisticated with the good control room that can give us reliable results. And the people who are conducting it also is extremely important from a quality control standpoint. And also for recommendation of monitoring and survey system in terms of reassuring the engineers as they build their buildings, what kind of devices that are available that they can use, and recommendation to test the building as they're building it and make adjustment if necessary before the building is completed. Other issues that we'll be dealing with is effect of differential shortening and restraining members, obviously due to outrigger or to floor framings or a very large member restraining other issues, so that's another topic. Special topic and impact of the overall movement, and obviously we'll provide the references and acknowledgement and contributor to all contributors to this. Obviously, this is some of the projects that I've done in the past while I was working with SOM. This is a pretty sophisticated program that use Gartner-Lockman method, the GL20 model, and that has a pretty detailed correction for steel reinforcement and CFTs and so on and so forth. And essentially, we will go into, I'm not going to go into the detail of it, but we'll big background on theory, how to evaluate it for both elastic and creep and shrinkage. This is slightly different from the previous guidelines that were provided by Fantel and Gauche and many of these, but now we have ACI and European standards that have a different recommendation. Again, I have a lot of information related to a database which analyzed pretty well. So all of these things, without getting into too much detail, will be included. Shrinkage strains and compliance. One of the difference between the old methodology and the new one is how to deal with the creep. Previously, we only dealt with the ultimate creep coefficient as one. Right now, we're dividing it into two components. One is the basic creep, and one is the drying creep. And the drying creep is more or less related to shrinkage. And for this material with a very low water cement ratio that goes up to a range of 0.2 to 0.3%, that could have a significant effect on our evaluation. And the problem, you can be conservative, but if you are not consistent, it could result in a major problem with the differential shortening. Again, these are just, so we'll have a theory. It's already developed, which I think we will, I'll just skip through this stuff very quickly in terms of how to evaluate it and probably give the formula on how to develop potentially a computer program. And again, this theory is not only applicable to, as I mentioned, to reinforced concrete, but it could be applicable to composite and CFT members that are not easy to deal with in terms of having enough confidence in terms of the correction program. So again, we can deal with the concrete, SRC, and again, CFT, concrete fill tube columns. Again, with this program, we also tested it. Unfortunately, we have some Japanese background on somebody who had done really real test on a CFT, and it's just a small sample. And we tested the program to make sure, in terms of the accuracy of predicting these strains, and essentially we came to be very close. Again, to include correction program and guidelines and transfer of forces between real time between steel and concrete. And this is practically some of the analysis program that I used in BUH Dubai, and it's pretty much have demonstrated that it is very, very accurate in the predicting the building movement. Again, and then at the same time we did instrument several building in Tower Palace 3 here in Korea. At the time I was with SOM, but Samsung was able to support this project and instrumenting it. And with that, we installed, again, strain gauges in the rebar, in the concrete, and also in the structural steel members, and including the concrete core. And as you can see, there is a pretty good correlation between actually what we measured, what we predicted, which is right smack in the middle, and what we actually measured between the steel and the concrete. So this is as good as it's going to get. This is another column. And also we started looking at overall verification of the total shortening in columns at different levels. And our prediction was pretty good. Again, as I mentioned earlier, we started looking at concrete material, just an example of BUH Dubai, where we are really dealing with material of different characteristics than we had previously and historically, and that should be also put on the table. And that's about it. Obviously, the ingredient, as I mentioned, the concrete is no longer what we used to have. It's becoming more a composite material that has to meet a very different kind of requirement than the concrete that we used to have. And because of that, we're getting higher quality, very, very low shrinkage, very high flow, higher stiffness, and so on and so forth. It's just, we again did a lot of tests, again, this is the first time I just thought about the program and what we can do in order to develop these guidelines, and I hope it would be not just a guideline, but also of real good reference for every engineer. Again, we intend to invite a lot of people, both internationally and also part of the Council of Tall Building members, and a lot of practicing engineers and code committee members and so on and so forth to contribute to this document. Thank you very much.
Thank you very much.